Hello everyone, my name is David Pan. I am the CEO of SDChain. Today I'm going to tell you the story about what we do. I'm sure that for those of you unfamiliar with SDChain, you might have some questions. I will spend this video session to discuss the following: SDChain Introduction, Technology Architecture, Product Introduction, and our long-term objectives. Why SDChain? Why do I believe that IoT plus blockchain could solve some key challenges facing our society in the 21st century? When looking back to human history, we see that 5,000 years ago, our civilization evolved into agriculture-focused farming society. At that time, people started making tools for harvesting food. For thousands of years, human labor was assisted with primitive tools. Until 300 years ago, we started Industrial Revolution, when machines helped us with much labor-intensive activities. Steam engines gave us mobility, while electricity gave us an energy source to power machines. The ability to power machines led us to the Internet revolution 30 years ago, when people improved communications worldwide. We started having cost-effective personal computers, mobile phones, consumer electronic devices, and other conveniences that were not available 30 years ago. In the progression of human society, we can see some of the key drivers behind technology advancement. Our basic human needs are to have a decent and meaningful life where we have clean food and water, proper clothing, sustaining healthy living, and having plenty of energy to power machines to help us work. These basic needs led us to search for technology innovations that could improve our lives. The advancement of technology-driven machines, or things, has led us into 21st century with a brand new era of the Internet of Things. SoftBank has estimated that over the next 20 years, there will be 1 trillion connected IoT devices worldwide. Looking a little bit closer, in the real world where average people like you and me live, today, Earth has 7.6 billion people. With scarcity of food, 790 million people barely have enough food to eat. That's 1 out of 10 of us. With lack of healthcare, 400 million people would never have the luxury to see a doctor in their lifetime. That's 1 out of 20 people among us. This is not to mention there are many more people that can't afford healthcare. With scarcity of electricity power generation, 1.2 billion people are not able to receive electricity. That's 1 out of 6 of us. For those of us fortunate enough to live in better conditions, we're however not fortunate enough to ignore these problems. Due to the current state of uneven resource distribution, terrorism and ideological warfare are increasingly dividing up the haves and the have-nots. While the early part of 20th century, prior to the 2 Great Wars, mankind faced the challenge of identity consensus, it is different this time. In the 21st century, in my opinion, this is the most challenging time for mankind's mission consensus. Yet, I choose to look at the world as glass half full. The worst of times often offer great opportunities for change and innovation. Let me give you an example. In 1984, at the height of the Cold War era, a global non-profit organization called International Standards Organization, or ISO, published a communication standard called OSI Model, which started an Internet communications consensus standard adopted by countries and tech giants worldwide. For those of you that have learned about OSI Model's 7 layers in school or at work, you know how important this standard participated in kick-starting the information technology industry. OSI Model solved a very serious problem at that time: the standardization of worldwide communication consensus among machines. With machine communication consensus, people could communicate with one another across the globe better. Information exchange through digital media allowed people to resolve differences better and misunderstanding faster. While ISO's OSI model could not claim the credit for ending the Cold War alone. Incidentally, the rise of IT startups at that time, including new IT giants such as Cisco, Apple, Microsoft, and others, has contributed to the prosperity of US tech sector and the global economy for decades to come. 30 years later, in 2018, will we once again achieve the consensus of working towards resolving global issues? ISO IoT Six-Domain Model aims at achieving the consensus of 1 single IoT standard among 30 participating countries, tech giants, and innovative IoT companies. The purpose of having an IoT standard is like having everyone agreeing to a framework of working together allowing everyone to implement projects and innovations on top of this framework. With such an agreed framework in place, everyone can utilize their core competency and expertise to solve market challenges, knowing that others are working alongside them to build this ecosystem together with a common language. The end result is that companies save a lot of time and money building the same thing from scratch when collaboration is enabled across the ecosystem. There are 6 key domains in this IoT Six-Domain Model reference architecture: user domain, application and service domain, sensing and actuating domain, physical entity domain, resource interchange domain, and operation management domain. How did these 6 domains come about? ISO 30141 standard, or commonly known as IoT Six-Domain Model, has gone through 4 years of discussions among scientists from 30 countries. China initially started the standard's proposal in September 2013. The process included new work item proposal, working draft, committee draft, draft international standard, final draft international standard, or commonly known as FDIS. I'm pleased to inform everyone that approximately 1 month ago, IoT Six-Domain Model has passed draft international standard and is ready for FDIS voting in a few months. Once passed in May or June this year, IoT Six-Domain Model will be the global IoT standard, similar to the significance of OSI model passed 30 years ago. Let me quickly introduce the framework of IoT Six-Domain Model. The framework divides functionalities into 6 domains. They are user domain, which governs user interface and account management; application service domain, which governs users' application and service needs; sensing and actuating domain, which governs how IoT devices detect information and execute commands from the application services; physical entity domain, which includes physical entities such as the targeted objects and environment from which IoT devices can both gather data and execute commands upon these physical entities; resource interchange domain, this is where data is shared on secure permission basis; and finally, operation management domain, which governs the entire framework with operation control, management, and auditing functionalities. As you can see, IoT Six-Domain Model is aiming at delivering physical world's data communications among people and machines, as well as machines with other machines. Blockchain technology is utilized in a distributed peer-to-peer network environment where transparency and credible rules enable users and machines to trace previous transaction history. In the IoT environment, the following blockchain functionalities are crucial: distributed ledger for scaling data transactions, block modularization, anti-counterfeit security, transparently trusted data transactions, and high reliability. Blockchain's value propositions to the IoT industry are as follows: high security and privacy, authentic information acquisition and recognition, reliable network and data transmissions, scalable resource management and architecture. In the end, the entire IoT Six-Domain Model combines the practicality of physical world's IoT requirements and the value propositions of blockchain technology. In this convergence of IoT and blockchain, SDChain was born to commercialize the IoT Six-Domain Model framework. How do we make this work at a technology architecture level? SDChain, the commercialization initiative behind IoT Six-Domain Model, is centered around 2 key implementations. On the left-hand side, we take into account of user-centric services where we consider real-world use cases as applicable in the IoT environment. From there, on the right-hand side, we fine-tune functionality modules to support use cases. SDChain as a public blockchain will continue to be optimized and refined to serve the deployment needs of new use cases. To summarize SDChain at a higher level, you will see 4 layers. From the top, user layer, service layer, core layer, and base layer. These 4 layers are further integrated with SDChain cross-layer functions for intra-layer communications, which I will show in the next slide. In this diagram, please look at the 4 functions in the cross-layer functions section. You will see that we have 4 key functions that interlink 4 layers together: development, operation, security, and supervision audit. These 4 cross-layer functions enable the 4 layers above. SDChain's consensus algorithm is based on SDFT to compare generations of consensus algorithms. Bitcoin at blockchain generation 1.0 confirms a transaction at 3,600 seconds. Ethereum at blockchain generation 2.0 confirms a transaction at 17 seconds. At generation 3.0, there were various improvements made to improve transaction speed. At generation 4.0 with SDFT, SDChain can confirm transactions at less than 5 seconds. At SDChain, more technical optimizations are being made to improve transaction time. As an open source developer project, SDChain also makes it possible for cross-chain contract model support. This is especially helpful for other blockchain system developers to integrate with SDChain. Blockchain Generation 4.0 is all about integrating real-world IoT data use case needs on blockchain. To do so, we hope to foster an open and collaborative IoT developer and system integrator community. Our developer forum will be available for developers shortly at our beta release in April 2018. So what's it like to have an IoT application running on SDChain? Let me walk you through a few applications. The agriculture industry has tremendous room for applying IoT technology. With SDChain, starting with user domain, you'll see users such as farmers, insurance companies, food processors, and government agencies, and others that are participants in this industry. As application requirements, you also see that farmers, consumers, and retailers are interested in having services and applications that help them get a better view of the supply chain process. At the application service domain, service platforms are available to users with application requirements such as agricultural source traceability platform that provides full source authenticity data to users. At sensing and actuating domain, service platforms above call for IoT equipment to work for either producing data or executing commands from service platforms. At the physical entity domain, IoT devices from above interact with monitoring targets or actuating commands automatically to interact with the physical entities. An example would be when a humidity sensor detects that soil is too dry, an IoT-enabled water sprinkler is actuated to water the soil. At the resource interchange domain, data would be provided for free or for a fee to other data aggregators. An example would be using weather report data that would be helpful in forecasting water needs for the upcoming months. At the operation management domain, third-party operators and auditors have the capability to monitor and assist the operation of the agriculture supply chain. This may include government regulatory agencies that are interested to enforce cold chain policies to ensure food health and safety. On a separate note, Dr. Jay Shen, the co-chairman and chief scientist of SDChain, is an investor in fish farming operations. SDChain is being deployed at fish farms for IoT data acquisition and machine automation. As you can see from the previous slide, relevant agriculture finance applications could be applied where local agriculture credit unions, banks, and insurance companies will be interested to use data to provide credit, finance, or insurance. This will lead to much needed innovation in the agriculture sector that will encourage more efficient use of natural resources coupled with IoT technology. The innovation doesn't stop at financial applications from agriculture sector. Secondary industries supporting agriculture sector could be innovative for more efficient production. The agriculture IoT D apps running on SDChain could enable more industry participants to collaborate. Each participant could focus on their core competency and work with others on SDChain to grow this agriculture IoT D app ecosystem. The healthcare industry also has tremendous potential for leveraging SDChain for improved efficiency and quality control. Starting with user domain, we see that hospitals, pharmacies, nursing homes, and other organization users have use case applications. These use cases include how doctors, pharmacists, nurses, patients, and patients' family members need healthcare data. Most importantly, they need actionable intelligence to automate machine executions. I will use elderly nursing home as an example, as I used to provide financing for nursing homes. At the application service domain, users send requests to a platform service such as Intelligent Elderly Service Platform that requests for monitoring and execution of services. I will use a clean air quality service as an example. The service platform communicates with sensing and actuating domains IoT sensors and actuators on the service needs. On the IoT sensor side, These machines include temperature, humidity, air quality sensors, and other devices installed across the nursing home. The execution actuators include HVAC, air purifiers, and others. At the physical entity domain level, the IoT sensors at the nursing home continuously detect nursing home environment building variables. Should an anomaly occur, HVAC and air purifiers automatically go to work to increase air quality to the required service level. As you can also imagine, other physical entities such as patients and building janitorial staff could be monitored and alerted as building conditions change. At the resource interchange domain, such data could be provided on a secure permission basis for data exchange. HVAC and air purifier manufacturers would likely want to know how to make better next-generation devices for nursing homes with aggregate data sets from dozens or hundreds of nursing homes. At the operation and management domain, local healthcare regulatory agencies would want to ensure that elderly citizens are living comfortably in nursing home environment. These agencies, on secure permission basis, can tap into data streams to monitor the quality of these nursing homes. SDChain is pilot testing deployment with a textile manufacturer. In the process, we have gained some manufacturing insight. Starting with user domain, a textile manufacturer sources materials from other part producers. Use case applications are such that retailers, designers, and consumers want to have a transparent understanding of source origin and quality. Using a New York-based clothing designer use case as an example. A clothing designer wants to promote social responsibility to its brand by purchasing materials from a homeless women's shelter in Bangladesh that trains women to make textiles. At the application service domain, the designer utilizes source tracing service platform to ensure that these materials are indeed manufactured in the shelter. At the sensing and actuating domain, IoT sensors at the shelter coupled with shipping logistics data could detect the input and output of materials being delivered to the shelter and shipped out in the physical entity domain. Such data would then be sent to resource interchange domain for data aggregation, as well as providing such data feeds to the designer in New York. The authenticity of such source tracing could provide the added social responsibility branding that the clothing designer could certify to the public. At the operation management domain, regulatory agencies and nonprofit donors to the shelter could see how their funding for homeless shelters are making social impact and improvement to these women's lives. As I mentioned earlier, 1 out of 6 people in the world does not have access to electricity. There are various issues with the energy industry that are beyond the scope of this slide discussion. But one thing SDChain can do is to serve the energy sector by breaking down some barriers of data flow via blockchain. Previously in my career at ARS9, I used to review financial models of solar power plants and related power purchase agreements for institutional investment purpose. Let me walk you through what goes on in a solar power developer's mind and how he could benefit from SDChain. At the user domain, a solar power developer needs to raise 20% equity financing, 80% asset-backed financing from banks to set up a solar power plant that runs for 20 years. Banks need insurance companies to insure the equipment from natural disasters, as well as seeing power purchase agreement from local utility companies. 20 years is a long time, and there are many risks involved. At the application service domain, the power developer proposes to these financial service companies to set up an energy measurement platform service that gauges energy production to be sold to utility companies. This is where the plant's cash flow income is derived. From there, a second service is set up to monitor the operational status of the power generation equipment that contains data feeds transparent to all financiers involved in this project. At the sensing and actuating domain, IoT sensors produce data based on temperature, sunlight exposure, while cross-referencing the actual energy production output to ensure that solar panels are operating correctly in the physical entity domain. Should there be an anomaly, an alarm is triggered to maintenance crew to conduct on-site examination. At the resource interchange domain, such operational data spanning over 20 years could provide solar panel manufacturers significant R&D data for technology improvement. At operation management domain, energy regulatory bodies could get access to the data stream to ensure that clean tech energy production is starting to make an impact and to foster and grow solar power development in their region. Banks and insurance companies could audit the data streams to refactor their risk assessment per project. As risks become open and transparent, it is a lot easier for banks and insurance companies to provide capital to foster the growth of clean tech industry. So how do we make this work? Without a solid plan in place, ideas remain ideas. Let me share with you our plans to bring SDChain to you. A few slides ago, I have shared with you 4 key industries we wish to target. Over the next 5 years, we will be focused on these 7 industry ecosystems: healthcare, environmental protection, manufacturing, energy, transportation, logistics, and agriculture. The primary reason why we choose to target these 7 industries is that we have an in-house industry expertise in these areas, as well as having started pilot testing and commercial discussions with key players in these industries already. Over the next 5 years, our industry partners will issue press releases with us as use cases become available. In the past, as many of you have already known, in May 2017, SDChain project officially kicked off with design and planning. In October 2017, SDChain completed our initial development of the key layers that lay the foundation of our IoT blockchain network. This year, in April 2018, we will launch our beta version online with an open source repository inviting developers globally to participate in the beta group. The purpose is to test, modify, and fine-tune the system. In August 2018, SDChain is scheduled to release its network release online for public blockchain commercialization. In December 2018, we will start announcing collaboration results with IoT partners and data customers, jointly growing SDChain ecosystem globally. Some of you may wonder how SDChain's business model works. On the right-hand side, you'll see that data buyers such as big data firms, management consultancies, financial service companies, and industry operators I highlighted earlier make up the need-to-know customer group of data buyers. On the left-hand side, you'll see that data producers such as sensor makers, equipment manufacturers, software developers, IoT system integrators make up the need-to-sell partner group of data producers. As a non-profit organization based in Canada, SDChain bridges both groups' needs together to transact data production and purchase. In the end, buyers and sellers are happy as commercial values are derived from SDChain's network. To conclude today's presentation, I'd like to leave you with one final thought. SDChain's mission is to create a blockchain ecosystem with trusted IoT digital assets. Behind that mission, our vision is to give people in the IoT era a sense of purpose or mission consensus that you too could innovate upon the SDChain platform to do something to solve 21st century challenges facing us. Welcome to SDChain. Thank you.